Alright guys, once again we're continuing with composite functions, and remember in some textbooks you might not see composite functions, you might see compound function. So composite is the same thing as compound. And we're going to be taking a look at a question that involves an index higher than 1 for x. In this particular case we have 3x squared. So in question 1 it says given f of x equals 3x squared and g of x equals 4x minus 1, determine the following. So we're going to get straight into this question. So in doing the solution to this problem, again, for part 1, they're asking us to determine f of g of x. And not only just to determine f of g of x, but they're asking us to determine f of g of x in its simplified form. So let's take a look at this question. So again, the mother kangaroo is f of x. We're just using the analogy of the mother kangaroo to help us to remember. So we write the mother kangaroo first, and that is 3x squared. The x is being squared there. And the baby kangaroo is g of x, and that is simply 4x minus 1. Now, what is going to happen here, again, is that the baby kangaroo is going to jump wherever x is. So we are replacing x in the mother function with 4x minus 1, which represents the baby. So therefore, f of g of x simply means 3, and instead of writing the x now, I'm going to put in bracket 4x minus 1, but the x is squared, so if I'm replacing this with x, then this has to be squared as well. So what we're going to have here essentially is 3 times 4x minus 1 times 4x minus 1. And it's an expansion issue, and what we're going to be doing is targeting the expansion of the back part and then leave 3 for the last. So product of two brackets, so 4x times 4x, or positive 4x times positive 4x. I'm just going to put by the 3 here in the meantime. So 4x times 4x is 16x squared. 4x times negative 1 is negative 4x. Minus 1 times 4x is minus 4x. And minus 1 times minus 1 is positive 1. That is expansion that you would have done at the beginning of grade 10. So this is 3, open bracket, 16x squared. Now you owe 4 xylophones and you owe another 4 xylophones. That means in all, you owe 8 xylophones and then plus 1 there. And then each of these 3 terms inside the bracket now is now going to be multiplied by 3. Now, had they not asked me to simplify it, I would have probably just stopped here, but I'm going to expand and simplify the function, the composite function. So 3 times 16x squared is 48x squared, and 3 times negative 8x is negative 24x, and 3 times positive 1 is simply positive 3. And that is what the composite function f of g of x would be equal to. So in essence, I've finished this part of the question. I've done the composite function. It's also in its simplified form, which is 48x squared minus 24x plus 3. So we're now going to move on to part 2, which is asking us for g of f of x, which is completely different from f of g of x. So let's get into that part. So we're asked to find or determine g of f of x. So let's take a look at that part. We're asked to determine g of f of x, and in this particular case, the mother function is g of x, and g of x is 4x minus 1. The baby kangaroo comes next, which is f of x, and that is 3x squared. So what is going to happen is that the baby kangaroo is going to jump wherever into the pouch, and that is wherever x is in the mother kangaroo, or the mother function. So therefore, g of f of x is equal to 4, and wherever x is, we're going to replace that with 3x squared, and then minus 1. So we're going to have 12x squared minus 1. And that is what the function g of f of x would be equal to. That is g of f of x. All right, so I've answered this part of the question. Now part 3 is asking for g of f of negative 2. And since I have g of f of x, then finding g of f of negative 2 is simple, because all I'm doing is replacing x in g of f of x with negative 2. And if you had gone through the second method, you would have needed to find f of negative 2 first by plugging in negative 2 into f of x. And then whatever that value is, you plug in that value in x to find g of f of negative 2. That will be the second method. But I'm going to do the first, which means to utilize this. So part 3. Okay. So since g of f of x, which is what we found here, is equal to 12x squared minus 1, then g of f of negative 2, when you compare this g of f of negative 2 with g of f of x, you can see that x is being replaced by the negative 2. So all I'm going to do here is replace x with negative 2 in this function. So it will simply be 12 times negative 2 squared minus 1. Negative 2 squared is 4. And 12 times 4 is 48. And 48 minus 1 is simply 47. And that is what g of f of negative 2 would be equal to. Alright, I hope you guys found this video insightful. And we're going to be moving on to a second question where we're going to be looking at one of the functions being in fractional form, which is far more interesting than the simple functions we've been looking at. So I'll see you guys in the next video.